So if you remember from the last class, uh, so you are now you are well versed with you can understand what is geographic coordinate
Yes,
system,
and projected
what is a
coordinate.
projected coordinate system, right?
Yes, yes, yes.
And you have an understanding of what a pixel is, what digital
Yes,
number,
digital.
what variance
Yes,
is,
yes.
the main differences between a vector and raster,
Mm,
how the absorption in
yes,
the bands work,
yes, yes.
and how the electromagnetic spectrum, the extent of it,
Mm,
how it varies from the large wavelengths to the small wavelengths, and how
yes, yes.
every wavelength has a different kind of character.
Mm,
Okay. So, did we open this slide before? This one before?
what is this?
No, do you remember? Did we do it in the last class or something?
Uh, Not this slide, but actually in the Nansat portal.
Okay, okay. So now, as per your curriculum,
Mm,
so for example, in the last class,
mm,
we almost covered this.
yes, yes, exactly.
This part is yet remaining. I'll explain it just right now.
Okay.
And so we are gonna do this. But before this,
Mm,
there is a small part related to raster that we'll also cover today. Okay.
okay.
So now you know there are different bands, right? In a satellite imagery, we have different kind of bands. For example, just
Yes.
kind of uh, ignore that here this and this is visible. Just think that only you can see this and this. So it
Mm,
is a red band. Now if I
mm,
give you this two imageries, you
mm,
will see that there is something dark here, like
yes,
this portion.
yes.
As well as in this imagery, you see that there is something dark.
Dark.
But
Mm,
if I don't give you these imageries, but just
mm,
looking at them, can you tell
mm.
me what that thing is? You will
Might be
probably think that
river or
these are same.
something.
You'll be probably thinking that these both things are same, right?
Yes, kind of, yeah.
Yeah. But since now you have this imagery,
Mm,
you are able to see, okay, this is vegetation. And
yes.
here you can see this is water.
Water. Yes, yes,
But
yes.
if this was not there, you couldn't have been sure that this is water.
Mm, water.
So what happens is when you just look at a single band,
Mm,
so there is a character of the wavelength that how it responds from the object, the thing on the earth. So when I'm just considering the red wavelength,
mm,
so it reflects from vegetation in a very similar manner, it reflects from water.
water.
So they both are looking kind of similar in red band.
Mm,
So you can figure out that it is reflecting in this part, it is reflecting way different from where it is
mm,
reflecting in this part.
yeah.
So you don't know what it is, but you can make a general inference that this thing is different from this thing.
Yes.
But in case if this also was to be present in this image here,
Mm,
and I would give you this image, you couldn't figure it out like what this is and what
mm,
this is.
this is, yes.
So
Oh, it's the same
it
structure.
asks, so it kind of And so it is like a part of what are we trying to understand is why band ratio? Why
Mm,
not a single band?
mm,
If I give you just this image, was it of much use to you? No, no, right?
it's of no uses.
Now, similarly, here we talked about the red band.
Red one, yes.
Now we talk about NIR band.
Near it.
In NIR band, the reflectance of so this is just a reference image to understand the
Mm,
ground reality. But for example, this is vegetation.
mm,
So in NIR band, the vegetation reflectance was this much.
mm,
Whereas a fallow land, like more of a barren land, the reflectance value of it is also similar to vegetation only. So you just have this NIR band, you don't have this Google Earth imagery. I give you this imagery and ask you plot vegetation. You won't be able to do it.
mm, yes.
So we saw example of red band. In red band, vegetation and water are similar.
Mm,
In NIR band, vegetation and fallow land are similar. So n number of things, depending on their properties, they can be similar or different in a
different.
single band.
Mm,
So there is this another example of the near infrared. Now we have cloud here and snow here, but
mm,
both of them have a similar kind of reflectance.
mm,
So you could not basically, by at your end, if I just give you this image, you will not be sure that which one is snow or which one is cloud.
yes.
So consider an object, anything, maybe just consider vegetation or maybe consider water. When you consider that one object, so how it is behaving in every band, it is different and it will kind of form a graph, right?
Yes.
So vegetation reflects highly in near infrared, whereas as you go far away from the infrared, its reflectance decreases. Whereas for soil, the reflectance goes on increasing. Whereas you can see in water, until NIR, at some point you have its reflectance.
Mm,
Beyond, if you check in these bands, it has no reflectance in water. It will show you as dark as possible. It will show you a zero value because the water will not reflect any of this wavelengths here.
mm,
Okay. But since we had only a single band, it was not of much use. What if we what if we take two bands for an object? For example, for vegetation, here I take band 2
mm,
and band 4 of a satellite. Now I know that in this one it was particularly low, and in this band it was particularly high. So I use some mathematical operations. That
mm,
is, I minus from the pixel value of this, I minus the pixel value of this. So I would get a value of this line, like the difference, right?
yes.
So that will be a mathematical operation. So to understand it better, to understand the difference between two bands and highlighting like in NIR and in visible green light,
Mm,
the difference is using these mathematical operations. Wait a moment. Yeah.
okay.
So using these mathematical operations, I
Mm,
I create I do a ratioing. So that will help me understand that particular thing better. Now, for
mm,
example, if I just talk about vegetation,
mm,
so as we studied here, NIR minus red by NIR plus red.
mm,
So NIR
mm,
minus maybe red is red, green, blue. So that we are taking here the third band. You could, if even if you take second band, it won't be much difference.
mm,
So we take the red band. So this is a kind of a mathematical operation, NIR minus red, and the denominator here is like a value to keep our observation value between -1 to 1.
mm.
If you remove this, then also you will get a value. But just to understand it better, we add this. So our value remains between -1 to
Minus.
1. So for like in case of vegetation, this ratio of the bands is called as NDVI. That is Normalized Difference Vegetation Index. So uh, Y band ratio, a band ratio to understand the object with more clarity. Now, because of this, I am able to understand if for an area, if I have a NDVI value of 0.72, so this means it's a healthy crop.
Mm,
What if the value is near to zero?
mm.
It means it's maybe a old crop, it has not been harvested, or it is kind of infected crop, but it is not a healthy crop.
Then
So, uh, just for example, now we have this. We did not discuss NDVI in last class, right?
yes.
Did we discuss?
No, no, we
No.
didn't.
Okay. So basically, now because it ranged from -1 to
One.
1,
Mm,
because of how we applied the mathematical operations, now we understand 0.66 to 1 means very healthy plant.
mm.
0.33 to 0.66 means
One.
moderately healthy plant. 0 to 0.33 means
Unhealthy.
unhealthy plant or a dying crop. So -1 to 0, it means
Dead.
it can never be a crop. Either it is a dead plant or it is
Mm,
something else.
mm,
So if the value is like between -1 to 0, it could be anything else. It could be water surfaces, man-made surface, or rock, cloud, snow. But if you're sure that if there is a value, if it has to be a plant, it will be always between zero point 0.2 and 1.
mm.
Now, this was one of the examples of ratioing of band. One of the
Mm,
examples. Like it is also called as indices. The ratioing of the band, the
mm.
the ratio that the formula it is also called as indices. So if
Indices.
someone asks you, do you know some vegetation indices? Yes, you can say I know about NDVI.
Mm,
So there are many depending on the bands, how you subtract them, how you add them. So you can define many of it. Like there are thousands of indices as of the date. So these are some other defined kind of indices defined by other people. Uh, So here are some examples of these indices. For example, NDWI. So this is the green band minus the near infrared band
Mm.
divided by green plus NIR. So the more it is towards the positive side, the more it is near to +1, it shows that it is a water body. The more it goes to, the value goes to 0, the probability dies off. And as it goes into the negative, it may be something else.
Yes.
So similarly, like there are many, but for example, we have NDSI. In case you are confused in an imagery that if it's snow or cloud,
Mm.
then we use NDSI. So it will give you, it will extract, like for a snow, where it is snow, the probability would be near 1. If in
Mm.
case it's a cloud, the probability will be
Zero.
uh, near 0.
Yes.
So you can use this indexes to understand the images better. So it is kind of mathematical operations to use more than one band
Mhm.
to understand the objects in the image, right?
Yes.
There are some other examples, like just so sometimes this is not necessary that the operation should be in this form only. It could be this also. For example, R by band of NIR by red. So it is used in the applications of biomass. I'm not sure what LAI is. Uh, okay, leaf area index. So one of the agriculture terms. I'm
Mhm.
not so familiar to this. Okay. For example, it is the amount of leaf in an ecosystem.
Mm.
So for using that formula, you can find out, like the more the value is near the positive side, it means okay, it is a leaf.
Leaf. Yes.
Okay. So there's an ArcGIS tutorials on this also, or maybe anyways. Now in your system, just open Sentinel to download. Just write this in Google
Mm.
and open the first link. Go to explore data. Did the page open for you?
Yes. Yes.
Okay. Just hold on for a moment. Okay. So last time we explored a portal of Landsat, that is USGS portal, right?
Yes.
So this is the portal to download Sentinel-2 imagery.
Mm.
And but this portal has one good thing, that you can also visualize the indices, the band ratios, and directly download them. For
Mm.
example, if you choose a region, maybe I'll choose in India. Uh, if I
Mm.
choose this, maybe let's choose only Australia. Okay. So I've just chosen some random place in Austria. And now if I select a date for when imagery is available, for example, 14th. So for 14th, I see that there is no imagery at this side, but only here. I'll select maybe 28th. Yeah. So I have an imagery for this region in 28th. Just look for a date when your date imagery is available. Now, uh, an imagery, a raster image that we generally see in our softwares that we're going to use in our softwares, it is a combination of three images. So, like, when in a, for example, have you seen artists that they mix colors and they mix two colors and form a third color, right?
Mm.
On their palette, they mix two colors and form another color, right?
Yes.
So, in that same manner, when we take band 4, band 3, and band 2 of a satellite, in
Mm.
this case, like I have taken, in this case, they have taken band 4, band 3, and band
Two,
2 of
two,
satellite Sentinel-2.
two.
So that is red, green, blue band, red, green, and blue band. So
Mm.
the most fundamental colors are red, green, and blue. Using
Yes.
them, you can create or move into any color. You can make any color out of them, right?
Mm.
So when you add these three images into one image, it's just like mixing of palette. So the pixels add up and they form a true color image. It is actually this
Visible.
the currently imaging image that you're seeing, it's a true color image. It
Yes.
means how everything looks actually on ground, how everything is actually looking on the ground.
Yes.
So if you go to this place will look like this only. So that is why it is called as true color.
Mm.
So sometimes in many of the softwares, it is said the false color image is used. So this, in this case, we have used three bands only.
Mm.
The image is looking like this.
Mm.
So why we use false color is because if you if you look at this,
Mm.
and also your human eye is just able to
See this one.
visualize these colors. You can't
Yes.
see beyond this or
Mm.
here.
Mm.
But if you see, like your human eye is just capable to see until here.
Mm.
But if you see that NIR is reflected more than the green color of the leaf. So
Mm.
if you were able to see even NIR, it would not appear to you as green. The leaves would have been appearing to you more in this color, whatever the color it may have.
Mhm.
Did you understand the point?
No. Can you repeat this?
So, as I told you, the reflectance of any object is in each band. Like the
Mm-hmm.
sensor is sensing the NIR band.
Mm-hmm.
The sensor is sensing in this band, near infrared.
Yes.
That single wavelength, how it
Mm-hmm.
is reflected on each object is the digital number that the sensor catches.
Yes.
So if you look at vegetation, because your eyes are just capable to look here, not beyond
Exactly.
here, not beyond
Mm-hmm.
here.
Mm-hmm.
So you are just seeing it in green color you because you cannot look here.
Mm-hmm.
So, but it is reflecting, the vegetation is reflecting infrared more than the green color. If you were capable to look
Yeah.
beyond here, you would have seen
Mm.
it in green color, in this color of the
Red.
infrared,
Yes. Red. Yes.
not
Yes.
in
Yes.
green color.
Mm.
So since the reflectance of vegetation is
High.
so high in near infrared,
Mm.
the application of near infrared, particularly in vegetation for doing analysis, makes more sense to use NIR. The
Mm.
sensors we have, they are capable of capturing NIR. So they
Mm.
captured the vegetation in NIR, how it looks in NIR. We can't
Yes.
do it, but the sensor can do it, right?
Yes.
So it captured it in NIR
Mm.
and it gave us a grayscale imagery. It
Mm.
gave us the grayscale imagery that it is on you, whatever color you want it to be.
Okay.
So what false color means is the system has given it colors based on what it expresses the pixel best with.
Mm.
So for example, for vegetation,
Mm.
though it is not saying it is red color how it looks in NIR,
Mm.
it has assigned NIR itself the red color.
Mm.
But when we are taking the combination of just hold on a
Mm.
minute, I'm getting a call.
Okay.
So basically true colors mean how it actually looks on the ground. False colors means that they have taken three bands that is best to understand the ground. Not how it actually looks, but the best to understand the ground. So these bands are always fixed. That is in here. So they are like bands in FCC. So you saw the vegetation. Uh, yeah. So because the vegetation is more reflected in near infrared,
Yeah.
right? So they have, for just our understanding, called it as red band.
Red man. Yes.
It is not the red wavelength.
Yes.
Sorry, not the red band. They have
Yes.
just given the near infrared band the color
Red.
red for our
Yes.
understanding,
Mm.
and the green color as blue cover for our
Mm.
understanding, and the
Mm.
red color as green color.
Mm.
So uh, this comes up in many times, like we do the image processing in FCC, or in a interview they might ask you what are the bands that constitute a FCC.
Mm.
So the bands would be near infrared, green,
Green and
and
red.
red.
Mm.
So so now you know what a FCC is. Now you
Yes.
know what a true color is, right?
Definitely. Yes.
Do you have any confusion about FCC?
No, no.
Okay. So similarly, and I told you, like
And
if you use the
yes.
formula, you get NDVI. Now
Yes.
here is the visualized NDVI.
Mm.
So the near to the color one, they have given the output raster as green color for our understanding. Now, more
Mm.
it is near to one, the more it is green.
Yes.
And for example, this you mean you can say, okay, maybe he has not sown anything this year, or you can say the crop is in very early stage. So now you can kind of do a analysis of the imagery now because of the uh, indices, because of the ratioing of band, you are able to do the analysis of an image. So similarly, for example, I want to understand the moisture in this place. Now, from this imagery, I understand the vegetation. Now I want to understand the
Mm.
moisture. So, see, this area is so dense, highly moisturized. Not, no, no, it is maybe on the negative end. Yeah, red means almost no moisture. Blue means highly
Mm.
moisture. So this is kind of a built up area, like probably this is a city or something that there is less moisture here. And look in the forest. The
Mm.
forest zone has is highly moisturized. Even I think I can visualize clouds here. They also have
Mm.
a moisture. So similarly, we have just a moment. So similarly, we have SWIR, we have NDWI. So this one NDWI, the more it is near to the upper end, you can figure out it's a water body. You're sure, like this area. For
Mm.
example, if I give you a forest area and I tell you to find out, locate the water body in there. So you can use NDWI to find out
Mm.
the water bodies there. Or maybe in your country, if there is heavy rainfall and someone asks you to find out the
That is
probable
all.
dengue zones, you can use
Mm.
NDWI to find out where the water is stagnant.
Mm.
So similarly, you can see the path of the river in this very clearly.
Mm.
Now this one is NDSI. So in NDSI, there is a little error also. It also marks the. So sometimes you have to use both. For example, in NDSI, I'm able to locate where the snow is, but it is also uh, by it, like the character of it is also counting the water bodies in snow. So whatever you results you get in NDWI, you can just subtract with NDSI to get
Mm.
better snow area. Okay, this is my
Yes.
area of snow. So you could do these analysis. Now there is this custom part also. Here, if you want to understand something, for example, in custom, just go to index. And now, for example, NDVI, do we have NDVI? So there is something called as normalized difference build-up index. So with this, you can extract the buildings. Like this is a uh, kind of a built-up area. And for that, what we can do is uh, now since we are working with Sentinel-2, so the formula is SWI minus NIR. So it will be, we'll take the first SWR,
Oh,
band 11
okay.
minus band 8. So I take band 11 minus band 8. So these are all the houses, the built up area.
Mm,
So you can see the
okay.
houses or pavements. For example, if I go to Chandigarh, in Chandigarh imagery is not available for this page, so I'll change the imagery. Yeah. So now you can see all the houses, they're coming up in black.
Like dots.
So it has kind of, if you want to know in your city how much area is built up area, you'll
Mm,
find out the percentage of black versus the whole of the area. And so you'll get to know, okay, my city is 40% built up. So in this manner, you use the operations of band. So this all comes into, this is subdomain of how to use a raster from a satellite. So I hope this part is all clear, right?
yes, yes.
Any doubts in this?
No, no, nothing.
Okay. So just like USGS, you can log in here and you can
No, no.
just uh, like mark an area of your, like choose an area here, and then
Mm,
there's this download option.
mm,
But in USGS, you don't have the possibility to try and do this visualization.
mm,
Also, here they have given like, for example, the true color is 4,
yeah,
3, and 2. Now this is what it actually
actually.
looks like on ground. Now, if I take band 8, band 4, band 3. Now, this is the false color composite. So I
Yes.
know the green area in the city now. So similarly, you can try n number of possibilities for
Mm,
your analysis. whatever explores your the object you want to analyze, whatever explores its best, use that band.
Mm. And every satellite had different sensors, right?
Yeah. So these are from Sentinel-2. These are all from Sentinel-2.
Mm. Do we also have to remember the bands that band one is green, band two is red, or no?
Your voice is not audible.
Okay, so do we also have to memorize the number of bands that each satellite have, or it's not mandatory?
I would say if you have to kind of if you're maybe living in Asia and you have to give some exams, they will probably ask you the number of bands for each satellite. But
Hmm.
I don't know if that would be of any use in Europe. It's just
No.
for more of like exam purposes, but it is
Yes.
good to know that okay, like in Sentinel-2, band
Hmm.
8 is NIR,
Hmm.
whereas in Landsat 8 and 9, band 5 is NIR. So
Hmm.
it is good to know some of the bands.
Yes, the basics one.
Yeah. So what we do next is just a moment. Just hold on for a bit.
Okay.
Do you have QGS installed in your computer?
Yes, I have.
Okay. So, we will open QGS now. Just go to QGS and open it.
Okay.
Did we download some imagery last time? Did we download some Landsat imagery last time?
No.
No. Okay.
But I guess Harita has shared some images to download.
Your
I have.
voice is not audible, Asim.
Okay. I don't know if it's because of internet or what. Can you hear me now?
Yeah.
So, Nagendra has also shared some images as well before you. So I have these images with me.
Okay. Is there any way to share them with me and I'll have a look of it?
Maybe I can just share the screen or because it's of Austria Salzburg region.
Okay. No worries. Okay, just share your screen and I'll have a look and then we'll proceed further.
Okay, get to share the screen. Mm, okay, it's not here. Uh, Can you share? Okay. So these are the images.
Okay, True Color,
Uh,
NDVI, LST,
These are
optical.
all Sentinel-2 images.
Okay.
Mm, And these are the NDVI.
What is the size of the folder which
Yes.
has all these images?
Okay, let me check. Maybe I have the. Okay, wait. Sarita. Hmm, This one. It's 14 gigabytes.
Ah, in that case, it's too
I
heavy.
also, yes, but I have also the Gmail links of these images. Maybe if you want download some of them.
Maybe just send the link to me. I'll have a look if we can use some of them to do our applications.
Okay.
So I've seen that you have loaded some of the images in QGIS. So
Okay.
do you know some of the vector operations in QGIS, how things work in QGIS?
Yes. Yeah, just to okay. Where's the screen? 86. Like this one, how to add raster or vector and what else? Okay. Then where is this? Okay. Then I also know this. Okay. Where to download the plugins? This one. For ArcGIS Pro, I knew most of them because usually in UST we work on ArcGIS, but in QGIS, I have no such commands to know where the tools were. So just I knew that, okay, here we can just upload, how we can upload the raster or vector data here. And if we want to create different colors or something, we can do it from here in Symbonology text. And what else? These are the stuff that we have done before you.
Okay. Um, okay, anyways, you can stop sharing. Let's do one thing.
I will try to share the links. Mhm.
So what we will do is today, we will understand like basic digitization processes.
Okay.
So you, in this QGIS, you just go to new project.
Okay.
And when you go to your left, you will see that there is an XYZ tiles. You just expand it and
Okay.
you take the OpenStreetMap and drag it to either here or here.
Okay.
So the
This
like
is the
Google
base
Maps,
map.
there is, pardon,
This is the base map or what?
it is a kind of a base map, yeah.
Okay.
So just like Google Maps, we have OpenStreetMap and we have edited it here. So if you maybe zoom into, let's look for a city on there, Austria. There is Austria. Okay, let's go to Paris. Huh. Just go to any random place where you see buildings. Just go to any random place where you are able to visualize buildings. Did this map open for you?
Yes.
Yes. Um, Brother, Chandrapur. Now, I want to digitize something I see in my base map and I want to make it into a vector layer. So in layer, I will go to create layer and I will
Okay.
click
Where is
new
India?
shapefile layer. In layer,
Mm-hmm.
I will go to create layer and click new
New shape.
shapefile layer. Now I'll call it as polygon because I'm going to make buildings. So I'll call
Mm-hmm.
it polygon buildings. I'll choose if you remember, we studied that there are three kind of vectors,
Mm,
point,
point
line,
of
and polygon.
polygon.
So I will select a polygon here.
Mhm. Yes.
Now, if I want to add anything to the attribute, I
Mm-hmm.
can add it here. Maybe I
Okay.
will add building number. So look for an area by yourself and also do it along.
Okay.
Any city, anywhere, just look for any area
Mm-hmm.
and create a polygon. Just go to vector, create new layer, and in there, just give it a name and select polygon.
Yes, I have doing that again. You.
Give it a building number.
Yes, I have done that.
Done it. Okay.
Yes.
So now I have this. Now to add vectors to this layer, I go to this edit toggle feature that looks like a pencil. After I click here, there
Just
is,
a moment. I don't have this layer styling on the right side.
you don't have this pencil.
No, the right in the right you have the layer styling tab, right?
Which one?
In the right side, this which says layer styling. Not on the above, on the right side.
No, this one, this one.
Yes, 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 yes.
Uh, don't worry about it. Don't worry about it.
Oh, okay.
Uh, this, you have something like this now. The screen is like this, right?
Exactly, yes.
Okay. So, uh, now you have the base map in which you can see some places which you want to. Sometimes you have the raster in your background and you want to digitize something from it. So you
Mm-hmm.
make a file like this. You go to this edit toggle feature,
Mm-hmm.
and to add a new feature, you click this button.
That only one, but it's not working for me. The add polygon features. Okay, first I have to edit it. Okay, okay.
Yeah, first you need to click this, then you need to
Mm-hmm.
click this.
Add polygon, yes.
Now you make you click on each corner, and when you want to finish, you right click it.
Okay.
You need to first, you need to first at the endpoint, you first need to left click and then right click it. So it
Okay.
will ask for ID number. Just give it one. Did you were able to do that?
Yes, ID one.
Now, in your tab here, just right click
Mm-hmm.
and just see if snapping toolbar is on.
Okay, I done that. It's on now.
So when it's on, something like this magnet will appear. So
Where?
also,
Okay, okay, yes, yes. It's appear
uh,
now.
enable this magnet.
Mm-hmm.
Okay. Just give me. No, no. Okay. So what this magnet means is, since you already created a layer, now I
Mm-hmm.
want to create another box here, but I don't want when I go over this, you will see that there is something of pink color that is showing up.
Uh,
That means snapping, that it is giving already the vertex or the vertices of the pre-existing shapefile to us for
ah,
reference.
okay. So
So,
it will not overwrite it.
huh?
So it will not overwrite the this line.
No, no, if I turn this off
Hmm?
and I want to make a new polygon here, but I won't be able to properly mark the corner of it. But when I
Hmm.
have this and when
Hmm.
I'm over this and this
Hmm.
pink shows that it means I'm exactly over that corner.
Okay.
So, for example, now I turn on the snapping. I make another. Similarly, I make
And how to delete vertices if I have done something wrong?
I will tell you that.
Okay.
So, for example, I created these four, right?
Hmm.
Now, I will turn off the editing with this one and it will save it. Now, I will go to property polygon buildings. I will choose the, where is it? The attribute table.
Okay.
In this, for example, if you see first, second, third, if you want to delete anyone, you just click toggle editing here
So,
and just select the one which you want to delete and you select it. It will get deleted, right?
way to delete it?
Huh?
Just type select this and how to just press delete.
If you go to the attribute table, you need to click this pencil.
Yes, I've done this.
When you click it, you
Hmm.
just click from this you can visualize which one you want to delete. Just for example, I want to delete this one. I'll go to this delete here.
Hmm.
Now
But
it's
for
deleted.
me, why didn't it work? But for me, it didn't work. Hmm.
Just a moment. Can you share your screen?
Okay. Like I have to start this one. Did that select these? Okay, wait, it didn't work.
No, you're not selecting it. If to select it, you need to click on that one, two, three that is on the left. That
Okay, this
in
one.
no. In the
This
very
one.
left there is very small one, two, three.
Uh,
No. Just go into the table itself.
this
Don't
table or this
yeah,
one?
here only.
This?
Yeah, just go a little left. Go down. No. Go a little left. Go down.
Hmm.
Yeah, select this.
Okay. I was selecting this thing. Okay. I've selected this one and now I have to go to download, delete. Okay, perfect. Got it. Thank you.
Yeah. Okay. So we'll take a 2-3 minute water break.
Yeah, sure.
Yeah. So it's 2:36 in my screen. I'll be back at 2:39. Okay.
Okay, perfect.
Uh, Shosad, are you there?
Yes, yes,
Hello?
I mean,
Yeah. Okay. So, you know now how to create a polygon. So, maybe let's create some buildings first. Well, it deleted this one. You also do it with me
okay.
simultaneously. Just create some buildings. So now, for example, I created 7 buildings.
Mm.
Let's create a new layer. Go to new shapefile
First, I
layer.
have to save it or I don't.
Pardon?
First, I have to save this thing, na?
Yeah, when you just click this again, it will
Yes.
give you the option to save it,
Okay. Perfect. Done.
right? Also, in case if you don't still the editing on, there is like this option also that is also to save only. So
Okay.
now we go to layer,
Mm-hmm.
we go to create new layer, we take
Mm-hmm.
a shapefile layer.
Okay.
Now this time I choose a line.
Mm-hmm.
I will choose line string. Just select OK. If you remember this one part here, so currently I'm working in this coordinate system.
Yes, WGS84.
Yeah. So if for example if you want to change it to this Austria Lambert or anything, you just need to search it here.
Mm-hmm.
For example, so here we have the Austria Lambert.
Mm-hmm.
I can just select and press OK. But I would for now work with because my zone falls in 43 in either this or I could
Mm-hmm.
just select WJC84.
Mm-hmm.
And so as also discussed yesterday, I told you like WGS84 is a ge geographic coordinate system. It's based on datum. The datum is defined for whole world, right?
Yes.
Whereas UTM was the projection of map and then the strips as I showed
Mm-hmm.
you. So it shows the area where it is just defined.
Yes. So it will be accurate just in this area.
Yeah, it would be more accurate than the 84.
Mm.
So it depends on your use case which you have to select, but just we have to make sure all the data we are working on needs to be in the same coordinate
Coordinates.
system.
Yes.
Just so now we select OK. Also, sometimes w- polygon and line can be used interchangeably. So we used polygon here. but for this row, I will use line instead. So you just click this pencil and then you go to add line feature. Now I create. So my line is not very viewable. What I will do is first I'll cancel it. Then I go to line properties. In symbology, I will choose a good width for it. I will maybe choose 2 millimeters. Then I'll press OK. Now, when I start making it, so similarly, we are able to do it for line. So, were you able to do for line?
Yes.
Yes. Hmm. Now we have polygon, we have line. So,
Hmm.
lines can also be used maybe in some other manners. Okay, for example, uh, maybe I take this polygon, I create a polygon that is from here to here.
Hmm.
Now I wanted to look inside the polygon because there were divisions. Now they are hidden. Now what I can do is, for my case, I will go to polygon buildings. I will go to
Hmm.
properties.
Hmm.
I will go to symbology. In symbology, I'll choose the layer.
Hmm.
Now, there's no transparent option. So I'll choose the this part, this opacity near this part. So it will kind of make it transparent.
Hmm.
So now I have this is the
Yes.
polygon, but I'm able to see what is below there.
Hmm.
So maybe I'll take a line now and I create a line from one end to the other end.
Just one question. If, for example, we did not match a line properly, can we edit it later?
Yeah, there are ways to do it. I will tell you those in also in coming classes or maybe today itself.
Okay.
Uh, just for example, Now I have enabled one other thing in snapping, that is here. That is enable
Okay.
snapping on intersection. So when two lines are intersecting and I
Mm,
hover over it, now I have this when the point is selected. The line
mm,
I made was a little wrong outside the polygon. So now I have snapping. I can snap from one point to another. Now this the width of the line is big, so it is showing it out of that point, but it is
mm,
exactly on that point.
mhm.
So there are many tools here that you can explore, allow overlap. Now in case we take points, the third time we now create a new layer, create layer, we call it points. We take the geometry to be point and we create it. Now I take this. So were you able to create the points?
Yes.
Okay. Uh, do you know about the SHB format?
Uh, yes,
No?
it's a shapefile format. Yes.
Yes. Okay. Now if I want you, if I ask you, okay, we have a certain kind of data here. This is a data.
Mm,
Now I want you to give it to your friend in a pen drive.
mm.
Do you know how to give that data?
In a shapefile format.
Yeah, yeah, but how? Like you have this here in your QGIS right now. How will you
Mm.
take the shapefile from here?
Like
You
from
just create,
project, you
huh?
go to export.
Yeah.
I have to go to project and then import, export, and then
Okay.
okay.
So what you will do is, for
Mm,
example, if I want to maybe give this data,
mm,
so I'll go right click here.
mm.
I'll go to export.
Yes.
I mean, I'll click save
Save
feature
feature.
as. So I will choose the place I want to save it. Maybe I'll save in a new folder. I'll call it polygon. So you see, it comes by the name ISRI shapefile. The shapefile format is owned by ISRI. Okay. Now, when
But
you
for
save
me,
it,
it's GeoPack.
pardon?
But for me, it's GeoPackage.
Then you have to go and change it from, is this any way to, are you getting another types here?
Okay, okay, because my format is GeoPack. Okay, I have select now easy shapefile.
Pardon?
I have selected the wrong format. When you save as vector layer, you have to select the format as well.
Yeah. So
Mm,
now you have it here as. Shapefile, and you save it. Press OK. It will also add it as one more layer here also, just for your reference. So the layer that
Uh,
you made, it's here. So if
mm,
someone asks you, okay, I want to open this polygon, so you don't just give them this. If you just give them this, it will not open. You have to give it them to them all of it.
yes. All fine.
Yeah.
Yes.
So, uh, just a minute.
Is there any way we can do digitizing with the help of AI or something, or we have to done it manually?
There are tools to do it, but
Mhm.
I think they're mostly paid tools.
Ah,
Uh,
so we have to do manually.
yeah. So you just feed them the image and they will digitize it, but they're kind of paid tools.
Can we also create that as well, or it's not possible?
Pardon?
Can we also create that tool or on our own as well, or it's difficult to create that tool?
So if you are very good with programming, yes, you can definitely create it.
Mhm. Like with the help of ChatGPT or different AI models, can we do that or
Uh,
difficult?
I particularly think that it is possible, but you need very high level of understanding of how to create it.
Hmm.
So for me, it's not my domain. I do not have
Hmm.
that kind of understanding. So maybe if you could, maybe ChatGPT gives you a workflow to how to actually do it. That
Hmm.
can be tryable. That can be tried, but I think it's very difficult also. It would not be really easy. It would be very complex.
Hmm. Got it. Because in the Harita, the what you can the course curriculum was also to create some sort of what you can say this tools as well. There are three modules, and I guess in the module one we also have to create a tool as well. So that's why I was wondering that is it possible? No, it's not this one. This is the foundation one. Apart from this one.
Uh, you mean the one at your college?
No, no. So basically, the first program was I choose was Geo Developer. I forget the name, but it also has three different tracks, and on these three different tracks, there are different kind of workflows we have to like do. And on task one, we also have to create a tool as well.
Okay, so
I think
basically, what
not
the
on
thing
this
is,
track.
uh, it may be possible, it may not be possible, but it outside my domain. For example,
Mm,
even in your case, uh, I will be just covering the phase one.
okay.
My expertise is just in the foundations. So
Conditions.
someone else will take care of this part.
Mm,
So
automation.
maybe it would be more appropriate to ask them if we
Mm,
can do that kind of thing.
mm, got it.
Because here I feel that maybe in advanced deep learning or something,
Mm,
you would be able to do it.
yes, yes, I got it.
So my aim is just to make the basics clear for you so that you understand what QGIS and remote sensing is all
Mm,
about. Okay. So now there is this part in many times in interviews or somewhere they ask you what an SHP is. So you simply tell them, okay, it is a format of shapefile. But then they ask,
yes.
what are the files associated with it? So whenever you save a shapefile like the one we saved, so it does not save alone, it always saves with many other files.
Mm,
So all of them have a kind of meaning. So
yes.
in this case, we have 1, 2, 3, 4, 5, 6. Sometimes there is one more file called as XML.
Mm, if we have the
So
data. Data.
yeah, so it depends. You can say if someone asks how many files are associated to it, you can say it could be 6 to 7 files are associated with it. Then
Mm,
what are these files? So for example, SHP is the main file. It
mm,
stores the geometry, like you have
yes.
created a point or line or polygon.
Okay.
This file just stores the geometry.
Mm,
Now, the latitude longitude associated to that file is stored here.
mm,
The position of your geometry dot shx.
yes, yes.
SHP is the geometry. SHX is the lat
Maybe.
long.
Mm,
Now we have dot .dbf.
that will
So
be.
what dot .dbf do is like here we made a polygon.
Mm,
In that we polygon, if you go to its attribute table, sorry, just save. Okay, anyways, when we were making it, we were
mm,
saving an ID to it, ID number.
mm,
So that ID number is, for example, if you think of that ID more of like a house number, so that
mm,
information is that we added here. This is the serial number on the corner.
mm,
This is the information that we added to our shapefile. That
yes.
information, it could be n number of rows.
Mm,
Those n number of rows and columns are stored in this database
mm,
file, DBF
yeah.
file. So tabular data in database format.
Mm,
So next we have is a projection
good.
format. Now
Mm,
when we made that shapefile, now when we made it, we defined it in a projection system. We gave it this projection system,
WGS 84.
WGS84.
Yes.
So this is not latitude longitude. Latitude longitude is in SHX. So for
Mm,
different projection system, latitude longitude will be different.
yes.
So when you are working it with the data, it is very necessary to know the projection system you want to work in. Otherwise, there will be errors. So that projection system is saved here.
Mm,
Then comes the spatial index file. So this file is more of a file which helps the speeds up the processing. It's like it interacts with this DBF to speed up the things. So it is more kind of when do you know in chemistry there is something called as catalyst.
yes. To
So
fasten the process.
yeah, so it works as a catalyst for the attribute format to be working. So
Mm,
in some cases the software picks this up to work more fastly with this. So, but this is
Okay.
out of our domain, but just we need to understand the very basic that it is
Okay.
a uh,
Catalyst.
catalyst
Catalyst.
file.
Yes.
Then comes also .cpg. .cpg is something how the software is dealing with your system.
Mm.
So how the shapefile you saved, it has to kind of, when you put it into a software, it has to also uh, talk with the system. So that is something like WhatsApp encryption. When you send someone a message, it is not
Mm.
sent in English, it is sent in some other coding format, and then it
Yes.
is converted at the user end into English. So
Yes. Yes.
similarly, it works. It works with the system on what you want to process the shapefile with. So it is not like how you're working here. This has its another way of converting things, and it communicates with the system.
Mm.
So this is dot CPG. So if someone only gives you these three files, dot .shp, dot .shx, dot .dbf, that will still open that will still open. They are mandatory. Like if someone asks you, what are the minimum number of files associated with SHP required to open the file? So it is
Mm.
these three. Else
Yes.
is optional. But
Yes.
you can, once you have these three, if you know the projection system, you can define this one yourself.
Mm.
But in case you have all of them, but one of the above three is missing, it will not
Mm.
open.
Yes. Correct.
So these are very important. .shp,
Yes.
.shx,
And dot D.
.dbf.
Mm.
Now, for example, in this you created, let me remove all the files for now. Let me kind of delete. No? I'll just remove all the layers. You also remove all the layers.
Okay. Point nine polygon.
Huh?
Point nine polygons.
Sorry, you're not audible.
So point nine and polygons, both three.
All of them, yeah, all of them. Just keep this OpenStreetMap. Remove everything else. Done.
Yes.
Now, the file that you saved. Did you save a file, right?
Yeah.
Huh?
Yes. Yes.
Now, in the file you saved, create a new folder.
Okay. New folder.
Just throw the SHP, SHX, DBF. SHP,
SHP.
SHX, DBF, and also take the PRJ. Now, copy it and paste in this new folder.
Yes. Done.
SHP, SHX, DBF, PRJ.
Yes.
Now you just take because they are in the same folder, when you open one, all of them will open. If they are in different
Mm.
folders, then it will not open. Now, when you take the SHP, it will show here, right?
Yes.
It shows.
Yes.
Now, now remove it
Remove.
and
Labels.
delete the PRJ file.
PRJ. Yes. Deleted.
Now take the SHP and open it. It is
Yes.
not here.
Yeah.
Now right click on it and zoom to layer. It is somewhere that is, it doesn't know where it is because
Hmm.
it did not have a projection file. Got
Hmm.
it?
Yes, yes, yes.
But when it had a projection file, it was projected at the right place.
Same location, yes.
Now, what you can do is either you can get a .prj file from somewhere associated to this, or
Hmm.
if you know the projection system, you go to vector, you go to database management tools,
Hmm.
and you click
Reproject.
reproject layer. Now I select this layer polygon and
He's
I'll
spinning
take
it.
WGS 84. Since
Hmm.
I was working here, I could maybe also choose this if I want, if I was working, if that originally the file was created in this or so
Hmm.
I'll take WGS 84.
Hmm.
It will create a new file of this polygon file, but add projection system to it.
Okay.
Now when I click run and I click close, now I go to reprojected and I click and I go to zoom to layer.
Nice. Nice.
So you understand the concept of this, right?
Yes.
Any
How
doubts
does
with?
the system knows that this is the location?
Yes. Uh, did you ask something?
Yes, I asked that how does software knows that this is the exact location because the projection or the lat long was missing from that file.
No, no, lat long was not missing. Lat
Okay,
long
okay,
is
SHX.
always there in
Okay,
SHX.
okay, 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 okay.
Lat long is there, but the
Hmm.
reference model of Earth was missing, the
Yeah,
.prj.
yeah, there is projection. Yeah.
Lat long is always there. So this
Hmm.
is important. Without this, you cannot make a shapefile. So this
Hmm.
is always there.
Perfect. Got it.
Mm, Just a moment, we'll try something else.
Okay.
But I hope that that projection thing was clear, right? You still
Yes, yes, it is. It is.
okay. So what we do now is uh, we'll do a small exercise to understand how to work with the attributes of a vector data.
Okay.
So just remove everything. Just keep the OpenStreetMap.
Okay.
Now go to layer, create layer, new shapefile.
Hmm.
Maybe we call it buildings. Okay.
Hmm.
And we take the geometry type to be polygon.
Okay.
Now I want to add some data to this.
Mm-hmm.
Maybe consider that these are four buildings and people of different nationalities live here. For example, one person from USA lives in this one from
Mm-hmm.
India, one
Mm-hmm.
from China, and one from another country. Okay.
Mm-hmm.
So I will make four polygons.
Mm-hmm.
So I will define like an attribute called country. I will keep it as text only.
Mm-hmm.
So I will add it to fields list. Then
Okay.
I add one another, that is the, I call it NO, or maybe I will call it B space NO. That is the building number.
Okay.
You need to do it simultaneously. Are you doing it?
Yes, yes, I'm doing it.
Okay. So I choose the building number.
Mm-hmm.
I will choose it as integer because building number will always be a integer.
Okay.
So I choose OK. Now, for example, if I create four buildings, when I create one building and I click stop, it will ask me the ID and the country. Ah, I did not add building number. No worries. So I add ID 1 and I call the country as India.
Okay, for me, it's asking three things.
Huh?
For me, it's asking three things: ID, country number, building number.
Yeah. So just make the building number and ID number same. Just take it as 1. And then for the next one too, as you create, just uh, choose the ID number and building number same. For this first polygon, make it 1 and 1.
Okay.
Yeah. So uh,
But in country name, it says null.
huh?
In country, in a row, it says null. Why is it saying null? Because of it's composed of integers?
For country, you had to choose text, right?
Yeah.
Did you choose integer?
No, no, I think no, no, it's text, but in this column, it says null value. I have to write it, na?
Yeah, you have to write India in capitals.
Yes. Okay.
So once you have created one,
Mhm.
we'll create another. I'll call it ID2, building number 2. I'll call it China.
Mhm.
Then I create a third one, ID number 3, building number 3, and I call it USA in capitals without a full stop. USA in capitals. Now save the changes by clicking this pencil.
Yes, I done.
Now my changes are saved to this,
Mhm.
and I will now add a new shapefile, create layer, new shapefile.
Mm.
I will call it as resident, the person living in that building. I will call it resident. I will select point. Okay.
Mm.
Now, because I know that person was from which country, I again
Mm.
add the one field that is,
Country.
I will add country.
Mm.
I will add it to the fields list. Then I will add the field called as name. That is the name of the person.
Mm.
And I click add to fields list.
Mm.
Then I'll add occupation
Mm.
of that person. It's also text, so I
Mm.
will add it. So you can add as many as you want. For now, we will add country, name, and occupation.
Mm.
Now we go to OK. Now in resident, when I go to toggle and I go to building number 1, I remember that I made it India. So ID
Mm.
1, country, capitals, India, name, maybe Rahul is living here,
Mm.
and his occupation is he's an advocate. Now I press OK. Now I have this. So ID number 2, maybe I remember the country being China. So maybe his name is Singhi. His occupation is driver. Then I go to third, add an ID number 3, country USA, and I name it as John, and his profession is in IT.
Mm.
Right? Save it. Now I have two different um, I have two different shape files
Mm.
with some attributes. Now the resident point shape file, it has the data, country, name, and advocate of occupation. Whereas the buildings, it has just the data, country. So for example, when you are working in this field and you come across something that you need to that now now the shapefile of your buildings, you want to add all the data from resident to this here.
Mm.
If you do it manually, it will take you so much time. So you want to, for example, you are working with such a file that it had maybe 100 columns
Mm.
or maybe 1000 columns. Doing that manually will be like crazy.
Yes.
So now I want this data, the occupation and the name. I want
Mm.
this or maybe any other data that we would have defined. I want that data also in my other data.
Mm.
So what I will do is in both of your datas, there needs to be one common column.
Oh,
For
yes.
example, we have common
ID.
as ID.
Mm,
The ID was same because we made it same. If generally it is not same for two different datas, but we have a common column that is country.
mm,
In that building also we have India, China, USA. In
mm,
this residence also we have India, China, USA.
mm,
Now I'll go to building. I will go to properties. I will go to join. Now, if you understood, I will go to building. I'll
mm.
go to properties. I'll go to join.
Right.
Here is the plus sign here. I'll click this one. Now I'm working on buildings and I want to add data from here. So I will join layer resident.
Mm,
So here I will choose the common field that was country. The target field is also country.
mm,
Maybe in in buildings, if the name of the column country was something else, but data
mm,
was same as country, you would have selected here something else.
mm,
You select the row attributes of the row that are common. The title could be different.
mm,
So, but we choose the one that has common values of the row. So
mm,
in our case, we have country and country.
mm,
So now there is this option. If you select it, you can only, maybe I just want to extract only names from here. I will
mm,
select name. I don't want the occupation. I don't want anything else. I just want the name. So I'll just click on names. In case
mm,
I want all of it, I will uncheck it.
mm,
If I want just the name, I will select names. And also when data from resident will be added to buildings, it will, for your reference, it will start as resident underscore name, resident underscore occupation, because
mm.
it is not an original data of buildings. It will be added from here to here. So it will be
Yes.
called as resident underscore the column name from here. But you
Mm,
can change it for your reference. You can call it anything. You
mm,
can change it here. If you don't want to change it, you want to keep it like a resident, just untag it and then click OK. Then apply. Now when I go to buildings and I see attribute table, now I have all of it. So for my reference, I can understand like where did I get these columns from? So I had picked it from the resident table,
mm,
right?
mm.
So this thing is called as attribute joins.
Eh,
So it forms the basic of your data exchange of in between layers if you want to exchange data. This is how you do. Uh, and it is in future classes, it will be very useful in SQL also, this
mm,
join thing. And yeah, there are some particular types to it that is called, we will explore it later, but just for reference now, it is called as inner join, outer join. So these are some things that will come later in our curriculum. But
okay.
if you want to just explore, you can have a look what a inner join is, what a
Outer
outer
join.
join is. So I hope you were able to join it in your
Yes.
data.
This is done that.
Yeah. So now I will remove it. Now I will. Um, do you have a downloaded Landsat imagery? Did we download any Landsat imagery before?
No, I have like the one which Nagendra shared, but I don't have other Landsat imagery.
Okay. So what you do is
Mm-hmm.
you go to USGS Earth Explorer. You go here. Just do it simultaneously.
Okay.
Do you have a login for this?
Yes, yes, I created this.
This login here. So were you able to open it?
Yes.
Just log in and go to any area you feel like. Go select any area.
Mm-hmm.
Uh, for example, I will choose Chandigarh only. Go to any area.
Mm-hmm.
Just click use map. Make sure the area is not very large. Just like it, this area is almost compassing the city. So one city. So select the date range. Make sure the date range is big. Maybe select from 1st January to current date. And then go to data sets. Now we'll choose cloud cover. Go to cloud cover first.
First, I have to select that date range.
Yeah. First select a date range. Take from 1st January
Mm-hmm.
to current date.
Okay. Then cloud cover.
Then go to cloud cover. Drag this end part to 30%.
Mm-hmm.
Then you click on data sets. Then go to Landsat.
Mm-hmm.
Go to Landsat level 2.
Mm-hmm.
We discussed what is level 1, what is
Yes,
level
yes,
2,
yes,
right?
yes, yes, yes.
So select Landsat 8 and 9 here.
Mm-hmm.
Go to
Results.
results. Now here you can see, okay, this blue thing is clouds. We don't want clouded imagery.
Mm-hmm.
Just go to that imagery and click this. You'll see the footprint of the image taken by the satellite. This is my area, but I have to download all this because the satellite has taken it. Now, if you want just an overview of it, you click here. It will take some time. It will show how the imagery actually looks. So I can see, okay, my area is not clouded. My region of study is not clouded. If my region of study was this, I would have not chosen this.
Mm-hmm.
So then you go to downloads. In downloads, you go to product options.
Wonderful.
And then this one. This downloads all the data together. If you are working on some particular band, you could download the particular band.
Mm-hmm.
But for our current example, I would say to you to download this. Just download and let me know when the download finishes. I will let you know the next.
Okay.
You have a high-speed internet, right?
Nah, yeah, but on my cell phone it's high, but I'm using the dormitory one. It's kind of a slow one. So it will
How
take
much
around
time will
10
it take
minutes.
to download this data set?
So right now it's saying 10 to 12 minutes.
Ah, okay. So
Mhm.
until you download, I'll show you what we are gonna do with it. Okay. Now in QGIS, if you have to add, there is in layer, you have add layer. If you have to,
Mhm.
for example, the shape files that we created before, if I want to add a vector layer, I will choose, I have to choose like all of it and then press OK. Ah, not all of it. Sorry, my mistake. Because uh, if they are in the same folder, we just have to choose
Mhm.
one more. So I go to layer, I go to add layer, I go to add vector layer. I choose
We can
only
also
the assets.
do that
Huh?
from we can also do that from data source management manager as well.
Yeah, there are multiple ways to do it, but
Mhm.
it's the most basic one. Just to select just select the SHP and it will
Mhm.
show you.
Layer
Don't
and
worry
data
about
layer.
the, pardon?
Okay, yes, I got it.
Yeah.
I have
So,
select to just one SHP file, not the all files, right?
not all files, just one SHP file.
Okay, works.
So this is how you add shape files to your data. Then
Mhm.
in another case, now I have downloaded the satellite image. Yeah. So what the imagery that you downloaded will be in tar form. That it is kind of
Mhm.
a RAR form only. So you need to click and extract it. Once you extract it, it will make a folder. In this folder,
Yes.
you will have the bands here. Like this is band one, this is band two, this is band three. So you'll get all the bands here.
Okay.
So go to your QGIS layer,
Mhm.
create layer, sorry, add layer. Now
Mhm.
because I know it is a raster layer, so I'll select
Mhm.
add a raster layer.
Mhm.
I'll go here. Now, for example, I just want to add band one. I'll simply add band one. Add.
If you have to select the all bands, then I have to select the all imagery.
Sorry, your voice is not clear.
So if I have to add all bands, so I have to select all the imagery
Yeah,
as well.
yeah. No, so, for example, now I go to
Mhm.
add raster layer. So the thing is, we mostly work with band one, two, three, four, five, six, seven. Uh, Banded. Okay. Yeah. So since it is Landsat, I forgot. I thought of it as Sentinel. Since it's a Landsat, for
Mhm.
now, these five are also enough. So, but just
Okay.
for reference, let's take seven. If you want all of it, you can just select all of the images. For example, I'm just loading
Okay.
these 7 bands. I press OK and I add.
Mm.
So all of the bands are shown up here now. These bands look like this. So you need to like now you want to maybe if you memorize it would be easier. For example, uh, which is band one, which is band two, which is band three, which is band four, which is band five. So
But this is
blue,
for
green, and
segment.
red, the most important. They are two, three, four. Near infrared is
Okay.
five. So these bands represent. So this is kind of the part of loading a raster. So it shows if you click the expand button, it shows you the digital numbers like the maximum
Mm.
reflectance value. Now, did we understand the part why every band looks in grayscale?
Yes, because of the reflectance.
Yeah. So you understand it is grayscale, but you can use any color to understand it, right? It is just like
Mm.
you can make it all green. So if I know it is band 2, though I know band 2 is green, green means at
Mm.
green wavelength. So for
Mm.
understanding, I can change the color to all green or any colors. Like you can just go to properties in symbology. If you go to single, let it be black to white 496. Let me do it for band 1. Well, I'll not use it. Maybe if I go here, I go to single band pseudo color, color ramp. I can choose any, even I can use multicolors to understand one single band also. Maybe if I choose
Mm.
this, see, or maybe I choose shades of green here. So the reflectance, corresponding reflectance is shown in that particular color. Color is just for
Mm.
our perspective, like how we want it to look.
Okay.
So now, as we studied before, the we studied that, right? That is in part two also. So we studied NDVI, right? Today.
Yes, yes, yes.
So now I have the bands. Now what if I want to create an NDVI by myself? I will go here and look for raster calculator. So I will choose this second one. This, the one with settings.
Your screen is stuck.
My screen is stuck. Working now?
Yes. But how did you go there?
Okay. So there is this search place here down.
Okay.
Just write on the left down here, write raster calculator. And then there
Mm.
will this second one. This one with the symbol of settings.
Mm.
Just click on it. It will open something like this, right?
Again, the screen is stuck. Okay, now it's work.
Did you get something like this on your screen?
Just a minute. Okay, the image is downloaded, I guess. Extract it. But for me, it's WinRAR file. It's not tar.
Oh, not to worry, but just extracted it, dude. Sometimes they
Mm,
upload in RAR, sometimes they upload in tar, sometimes they upload it in any formats.
Okay, so it's extracted. I have to upload. Okay. Data source, roster data sets.
Were you able to download it?
Yes, I'm just uploading it on QGIS.
Yeah.
So I have to do roster complete. Roster. For me, raster calculator did not work.
Why your raster calculator is not working?
Hmm.
Did you select the second one only? This one?
Okay, which one? No, it's not. There's no program that's no algorithm is showing in my screen. It's blank.
Okay, maybe go to plugins and
Plugins.
let's see plugins and manage and install plugin.
Hmm.
Try to look for here if you have raster. No, let's start from here. So you don't have raster calculator here.
Yes.
Are you typing it right? It is not possible. Raster calculator.
Okay, okay. Now it's there.
It is also here in raster also. Maybe
Yes,
this is,
yes. I got it. I got it now. Which one?
you can use any one. I would prefer this one.
Okay, I got it.
Yeah. So when you choose this, now if you remember, the formula to NDVI was NIR minus red by
Yes,
NIR plus red.
that. Mhm.
So I know in Landsat, NIR is 5, red is 4. So that is 5 minus 4 by 5 plus 4.
Mm-hmm.
So I create this, and in this I choose here band 5 minus band 4, and this next bracket I choose band 5 plus band 4. Do you understand it?
Yes.
Now I will choose a reference layer from this here. I will choose any of the layers because reference layers means it will create a new layer that has properties among any one because all of them are similar. I'll just choose any random and I'll press. Maybe I'll yeah, I'll press OK. Now, if you want to save it to your computer, you just go here and click Save to your file. But if you don't want it to save it to your computer, just want a temporary file, just click it here.
Save to
So,
computer.
huh?
Yes, yes.
So now you click Run and you close it. So it creates a NDVI file for you.
Mm.
Now you go to Properties, Symbology, you choose Single Band Pseudo Color. In this, you choose either spectral or turbo as you wish. You choose maybe turbo or you choose the wall color. Yeah, I will choose. I want this one. I will choose this one. Red, yellow, green.
Okay.
So I click apply. So um, so now you can we created NDVI. You can rename it as NDVI. So now for our in area, now I can see that these green areas is healthy vegetation.
Mm.
You can see from here 0.662 above. You can see the color grading. Like if you see this color, what that means. If you see something near red. So as we discussed here, now depending on these values, mm, mm, if you click on I, this I button up here, now when you click on a pixel, it will give you the value, any pixel. For example, here it is 1.3. So we studied that it's if it's less than 0.2, it's not a plant. So now no, it's
Mm.
not a plant. It can be anything else. But for the green part, if I go to this 0.4, I know it's a plant. So mm, like here 0.5, I know it's healthier than 0.4, 0.3. So if I go to the forest area, 0.47. It depends also on the season. So maybe
Mm-hmm.
this is autumn. So plants are not so in a healthy manner. But this is NDVI. This is for you to understand how the vegetation is in the area. So uh, we are kind of doing a mix of this week one and week two. So now you know many things like Landsat imagery, Sentinel imagery. What is, we'll talk about sensors, right? We know bands. We'll talk about different kind of satellite sensors in
Mm-hmm.
upcoming lectures. But now you need to create a map, but we'll do it later. But now you understand the basic that you will include in that map. Now you have an NDVI. We created an NDVI for vegetation. We'll also do this, but you are somehow familiar to these topics now, right?
Yes.
Okay. So for today, we'll just uh, wrap up now. But if you
Okay.
have any doubt in today's class, just let me know.
No, no, it's fine from my end.
It's fine. Okay.
Yes.
So on Sunday, as I already told you, I'm occupied somewhere,
Okay. No
and
issue.
maybe in future classes, I'll take one extra session, or I will somehow increase the duration and make the classes little longer,
Okay.
and I'll adjust the Sunday's lecture. Okay?
Okay. Perfect. Perfect. No issues.
Yeah. So just keep practicing doing the digitization.
Okay.
Uh,
Can
try
you also
to,
share the slides as well of today's class?
pardon?
Can you also share the slides of today's class as well?
Yeah, Mr. No. Okay, I'll send it to your email, no worries.
Okay.
I'll send it. But it has many slides. So I like, for example, you just scroll to the ones that are useful to you, right?
Mm-hmm.
There are some slides that won't make any sense to you.
Mm-hmm.
Okay, so I'll share this. Okay, for now we'll stop the lecture here, and
Okay. Perfect.
where is yeah. Okay, then we'll see each other on Tuesday, next Tuesday, right?
Yeah. Perfect. Thank you.
Okay, take care.
Okay. See you. Bye.
Bye.